All right, let's take a look at where you're at and how you're doing on this stuff. So last week the goal was to get to the idea of congruent triangles and the shortcuts, okay, and side, angle, those kind of things. That was the main idea of last week. This week, the next step is now, once you recognize congruent triangles, can you put it together as a proof? Okay, and so that's what we're going to work on today. And my hope is that we can get through some. I'll go through a couple more examples, possibly. There's a few things that I want to talk about. But then after that, then going through and giving you some time to actually work your way through some proofs and go from there. So that's kind of the plan for today. Okay, and then next week, trying to think next week, then we're going to wrap up chapter 6. And then the following week will be the week that we then start testing on it. Okay, so just a heads up on that. If you take a look at your warm-up today, a couple of trigonometry type problems, a couple of triangle problems from back from chapter 5. Okay, these are the types of problems. Again, you will see as the geometric connection standard in the on the test. Okay, back to previous material. And problem number 1 would be kind of almost more like an A-level type of problem, because of the fact that there's information that you have to find, then you got to use that information to find some other stuff, and so there's multiple layers that go into this, okay? So as I was looking around, it looks like quite a few people, maybe not everybody, but quite a few people in the first problem noticed if that's 30 and that one's 90, that means we've got a 90-degree angle there, which means this is a 60-degree angle, so we've got a 30, 60, 90 triangle. Then, if I took this height and let's say I slid it over, you can kind of break this triangle off, which means if that one's 45 and this one's 90, that means here we've got a 45, 45, 90 triangle, okay? So we got a couple of different triangles in here in order to find the shortcuts. And so, in the first one, 30, 60, 90, if we start here and work our way that way, we know that the hypotenuse is 20 feet, which means, what's the height? What does the height have to be then? Which the height is also the short leg of that triangle. You work backwards a little bit. Kind of what you got? Yeah. Remember, the short leg is always half the hypotenuse. Hypotenuse is always double the short leg. So if that's 20, that means that is 10. And therefore, the long leg is what? I think what's the long leg then? 17. Which is 10 square root of 3. Yep. So you get 10 times the square root of 3, which the decimal version of that, which we're going to need, is 17.32 approximately. Okay, so there's your first triangle that we were working with. And again, if the shortcuts in the triangles are not making sense, you could still set up like a sine, cosine, or tangent problem and solve for those missing pieces. You don't have to use those shortcuts if they don't make sense to you. Okay, so just a heads up on that one. Well, then if we keep working our way over, well, right in the middle here we have a rectangle, so that's 12. That means up here, that piece is 12. And now if we work over to our 45, 45, 90, we can kind of finish out all the missing information. Nice part is, if this is 10, I can slide that over. That means this is 10, right, that piece of information. And because it's a 45, 45, 90, we know the two legs are equal. So this piece is 10. And the last part then, solving for x, is what's the hypotenuse of my 45, 45, 90? Yeah, this would be 10 times the square root of 2, or again, the decimal version of that, if I remember correctly, is 14.14. Okay, 14.14. So now, if I wanted to find the perimeter, I've got everything going all the way around. I did ask you to find the area, which we can do because I have all the information I need. Okay, and so now if we go back, here's where again it kind of takes it up a notch, which is why it becomes kind of that more A-level type thing. We didn't just solve for missing side lengths. Now we're using that information to find something else. Okay, and you may or may not remember, you could have gone through and found the area of like each part, added those 3 parts up. That's fine. Or if you remember back to your green toolkit, the second one that I gave you for the year, on one side you had all the angle relationships, alternate interior, corresponding, vertical, all those kind of things. On the back side of that toolkit are all your area formulas. Okay, so that's another place that you could have looked. The area formula for a trapezoid, if you remember, is, it's just like the area formula for a triangle. Instead of base times height divided by 2, it's the sum of the two bases times the height divided by 2. So it is base 1 plus base 2 times your height divided by 2. Okay? And like I said, that's on that green toolkit. It's on the backside if you forgot the area formula for a trapezoid. And now, we've already solved for all the pieces of information. Now I just got to put them in the right spots. So, base number 1, does not matter which one's base 1 or which base 2. I'm going to start with the 12. Plus base 2, then I got to add that whole base. Okay, I got to put them all together, the entire length. And so if we do that, we get 39.32 times our height, which we found. We found that to be 10. All over 2. And now we just get an answer. Okay, just plug it all in and get an answer. Which, somebody does that for me. It's in the it's like 250-ish somewhere in there. Somebody help me out on that one. Somebody gets it, let me know, please. Like I said, your answer should be somewhere in the 250. Okay, so approximately 256.6. If I throw some units on there, we're in feet, and I just found an area, so therefore it is square feet. So 256.6 square feet is the area of that trapezoid. Like I said, you didn't necessarily have to use the formula, okay? You could have found the 3 different areas and added them up. You should still get the same answer, okay? It just might take you a little bit longer to get there is all. Any questions on that? Something along those lines? Any questions on anything there? Trigonometry plus area, kind of all wrapped up into one. Okay, then down at the bottom, the other warm-up problem for today. My hope is as you looked at this problem, there's 2 things that kind of came to you right away. Number 1, this is not a right triangle. And therefore, number 2, because it's not a right triangle, you should be thinking of either law of sines or law of cosines. Those are the 2 things that you should be thinking in your head. And on this one then, based on what you see in the picture, is this a law of sines or a law of cosines problem? What do you think? I'm sure what you think. What'd you do on this one?
Law of sines.
Okay, why'd you do law of sines?
Because,
You're right, by the way.
oh yeah, I know. Because of, angle side.
Close.
Side, angle side.
Still close.
What do you?
The other angle side.
Angle.
There you go. Because if you look at the picture, the information that's given, angle side. And that is what makes this a law of sines problem versus a law of cosines problem. It all depends on what you have. So if you remember back, law of sines is just the sine of one of your angles over the opposite side equal to the sine of a second angle over the opposite side. You are just setting up a proportion is all you're doing. So if I take the sine of 110, I'm going to put that over the side opposite, which in this case is x, that's what I'm looking for, equal to the sine of a second side length, or angle measure, excuse me, the 22 degrees, over its opposite side, which in this case is 30. Sine of 22 over 30. There's your setup of the law of sines, and basically what we just set up, like I said, is a proportion, which now we solve just like any other proportion. Cross multiply. We get x times the sine of 22 equal to 30 times the sine of 110. And now I've got to get x by itself. So last step, we divide both sides by the sine of 22. And now we're ready to type that into the calculator. In this one, I know it's going to be bigger than 30 just based on the picture. Okay. And so again, if you would please, somebody type that one in, or somebody, what'd you get for that one? 75.3, that sound right? Agreed? Yes? Okay, yeah, let's go with that. I like that better. Yeah, okay. 75.25. In this case, I did give you some units, so we'll just put 75.25 feet. And there we go. Okay, so in this case, you review kind of your test prep type of problems, which is always what the warm-ups are. They're kind of test preparation problems. We got a law of sines question, and we had a triangle shortcut question that then also led you to some area stuff. Okay? All right, let's go into the next part, and I'm going to actually skip to this. So on your red toolkit, what I want you to do is turn that over for a second. Because as we now go into proof, as we're now writing proofs more often, I told you that there's going to be 2 proofs on the test. I think I told you that? Did I tell you that? Or was that the other class? I don't know. Anyway, there's going to be 2 proofs on the test, okay? So you're going to have to work your way through that and be able to do it. That's one of the main ideas of this chapter, okay? There's 2 main ideas of this chapter. One is, can you recognize that triangles are congruent? And 2, can you then go ahead and prove it? Okay, those are the, they're right there as your geometric reasoning standard on this test. So if you take a look at the backside for a second, the proof toolbox, we put on the backside just some things to think about as you're trying to go through and do some proof. Some ideas of what you might want to put down for reasons or what things you might want to take a look at. A lot of times there's plenty of given information. Sometimes it's given to you in the picture. Other times you'll see today, it might just be given to you in words, okay? Vertical angles, okay? You know that vertical angles are congruent. That comes up a lot. You want to look for those types of things. Right here, I'm going to add something to this. Reflexive lines or angles. Remember, that's the reflexive property. Those are the shared sides or angles, okay? Shared sides / angles. And I'm okay if, when you do a proof, if you just want to put down that it's a shared side, or if you want to put down that there's a shared angle, I'm perfectly fine with that. If you'd rather just put down the reflexive property, that's fine too, okay? So either or is fine. If you take a look at the next one here, perpendicular lines, I added in the symbol, okay? There's the symbol for perpendicular right there. It's kind of that upside down T. So if you ever see that in a proof, you know that they're telling you that it is perpendicular, okay? So again, you may want to add that to your red toolkit. You may want to put that symbol in there. Quick question then as well, which we'll come back to it. We'll come back in it a little bit. Another thing, we talked about this one the other day, isosceles triangle. Remember, you got 2 congruent sides. That means you've got 2 congruent angles. And same thing goes the other direction. You got 2 congruent angles, that means you got 2 congruent sides. So there's that part of it. And then there's a few other things. There's some things that are talking about, we can get into the idea of definitions. So I could come through and you might hear me say, the reason is the definition of perpendicular. You might hear me say, well, it's the definition of a midpoint, which we'll talk about in a second. You might hear me say the definition of an angle bisector, okay, which we'll also talk about in a second. So there's a possibility that you might be able to use these definitions, and that's the other part that I wanted to kind of talk about. 3 in particular, okay? And if you want to, you don't necessarily have to add all of this, but if you want to add a little something kind of at the bottom of the toolkit, you're welcome to do so. So here's the angle bisector, which we haven't talked about a lot. But what does it mean if you bisect something? Say it again? No, go with it, because I can work off of it. What'd you say? That's okay, go with it. That's close, it's similar. Okay, so take something apart, and specifically when you bisect, what's the result? 2 equal parts, okay? So if you have an angle bisector, basically what you're looking at is right here. It divides the angle into 2 equal parts. So if you're ever given something in a proof and says, oh, this one is an angle bisector, the result will be 2 equal angles. Okay? You cut an angle in half. That's what it means to bisect an angle. And the result is 2 equal angles. So you won't see a lot of that necessarily, but it does come up from time to time, so I wanted to make sure that you're familiar with it. Second one. This one we've talked about. This one you should know, okay? But it's definitely worth revisiting. So again, there's your symbol for perpendicular. What does it mean if 2 lines are perpendicular? You're thinking slopes. They're opposite reciprocal slopes. That's a true statement. But just geometrically, if you look at a picture, what would you see? What does it mean if 2 lines are perpendicular, not using their slopes? Think?
Oh, they intersect at
90-degree angle is perpendicular. So perpendicular, if I tell you that 2 lines are perpendicular, what you then need to get out of that, by definition, is that they form a right angle. Okay, perpendicular lines form a right angle, always, by definition. That's what it means to be perpendicular. Somebody in the last class said that they intersect. Okay, two lines that intersect. And they do intersect, but the reason why perpendicular is special is because it's at a 90-degree angle. That's the special part of perpendicular lines. And then the last one, which is directly related to the first one, is the idea of a midpoint. And it's exactly what it sounds like. It is a point in the middle of a line segment. So therefore, if you know you've got a point right in the middle, just like an angle bisector cuts an angle in half, a midpoint cuts a segment in half. Okay, so right here, divides a segment into two segments of equal length. So if I were to see a picture like this, I know that point D is the midpoint of that bottom segment BC, okay? Because I've got two equal parts. Midpoint divides a segment into two equal parts because it's in the middle. All right, so just kind of a fairly quick idea of where we're headed. Now, what I want to do is actually go into, so go back to the warm-up that I gave you. We're going to skip the problem on the bottom, go to the back side. We're going to do those two. We'll do those two together. Then I'm going to give you an opportunity, hopefully, to start working on the homework that goes with this, where you can go through and practice this a little bit. So if we start, here's the first one. The first one on the back side. And I'm going to do this one as a two-column proof, just because that's my personal preference, and we haven't done a lot of those yet. You are more than welcome to do them as a flowchart proof, if that makes more sense, like I said. Depending on the way you see things, that will determine what you want to use. And both of them are right. All right, so if we take a look, notice, this time the given information is not in the picture. We're going to add it to the picture, by the way. It is given to you in words and symbols and stuff here, okay? So I'm going to take the first given, put it in my proof. So I know that segment AD is congruent to segment DT. How do I know that those two segments are congruent? Because it says so. Okay? They told you that they are. Therefore, that is given information. As you put stuff in your proof, make sure you also mark up the picture so you can see what's going on as you do the problem. So if I've got AD congruent to DT, that means that side is congruent to that side. Okay? Put it in the picture so you can see it. I promise it will help you. Then we move to the next one. We got another given here. We also know that segment ND is congruent to segment DY. Therefore, let me put that down. Segment ND congruent to segment DY. How do I know those are congruent? It's also given to you. Okay? It says so. And again, if you put it in the proof, mark it in the picture. ND congruent to DY. All right, so that's where we're at. Notice we're trying to prove the two triangles are congruent. Well, right now, I don't have enough information yet. So now we go to the picture, and we just try to come up with anything else that we see, anything else that we know has to be true. What do you think, Tara? Okay, how do you know that? The other two sides you're talking about? Is that a true statement, by the way? Yes, no? If those two sides are equal, then the third ones have to be? That's not a true statement. It works for angles. If the first two angles are congruent, then by default, the third one has to be, because it has to add up to 180. It is not necessarily true for side lengths. Okay, so unfortunately, I can't go that the last set of sides are congruent. That doesn't work out. I don't know that for sure. There is something I do know for sure, though, here. Yep, what do you got? And why? What kind of angles are they? There you go. So this angle right here is congruent to that angle because those are vertical angles. That is a true statement. One thing you got to make sure of, okay, and Adele kind of said those angles at D. because there's more than one angle, you need to use 3 letters in order to describe it. So if we're talking about this one, first off, you either need to call it ADN or NDA. Doesn't matter, but the D has to be in the middle. Okay, the letter D has to be in the middle. So I'm going to go triangle, or excuse me, angle ADN is congruent to angle, same thing on the other side, either YDT or TDY. Okay? The letter D, though, has to be the vertex of the angle, has to be the middle letter. That's the one key part. I'm going to go with YDT. And Adele gave us the reason already. How do I know those are congruent? Because they're vertical angles. So I'm going to put in here vertical angles. All right. So now don't lose track of what we're looking at here. I'm trying to prove the triangles are congruent. Do I have it? Do I have one of my shortcuts? What do I have, Lennon? I've got side, angle, side. Therefore, my final step, those 2 triangles are congruent by side, angle, side congruence. Okay. So if we put that in here, triangle AND is congruent to triangle TYD by side, angle, side congruence. And if I come back up again, part of the reason I'm not just telling you to mark up the picture just because I want you to do an extra thing, but because of the fact that now you can see that it's side, angle, side in the picture. That's why it's so important that as you put stuff in your proof, make sure you also match it up in the picture so that you can see it when you get to the end that you have, in this case, side, angle, side. Okay? If you like the flowchart idea better, let's say the flowchart in general makes more sense to you. The only difference is your first statement would go in one bubble with the given right below the bubble. Second statement and reason would go in the next bubble. Third one would go in the next one, and the final part would be down here. Okay, so it's just a different way of organizing it is all that's going on. Any questions on this one? Any questions at all? Okay, let's do one more together, and then like I said, then I'm going to kind of turn you loose and let you work and see, and I'll come around to check on you and see if you need any help or what's going on. Okay, so here we go. I'm going to do another 2-column proof only because, again, to me that makes more sense. Okay, if you would rather do a flowchart proof, you are welcome to do so. Okay. All right, I'm going to start with the very first given again. Okay, whatever they tell me, that's where I'm going to start. It's a good place to start. So they tell me that I is the midpoint of RA. Let's start there. I, and I'm going to abbreviate, is the midpoint of segment RA. How do I know it's the midpoint? Because it says so. Given. So there's step number 1. I just took the first thing that they told me. Or if it was in the picture, then you would just take the first thing out of the picture and put it down, list it. Now, if you notice, I did not say anything about congruent sides, congruent angles. I don't have any of that. I just said it's the midpoint. But based on what we just talked about a little bit ago, therefore, what has to be true? Yep. Yep. If I is the midpoint, that means it cuts that segment into 2 equal parts. Okay? So RI is going to be congruent to IA, okay, or AI. Doesn't, as long as you got the 2 letters, it doesn't matter which order they're in. So segment RI is congruent to segment, we'll say AI. And in this one, this is one we haven't dealt with before. That is the definition of a midpoint. By definition, if that's a midpoint, then it breaks it into 2 equal parts. Okay? So our reason is going to be definition of midpoint. Definition of midpoint. That's what a midpoint does. Cuts a segment into 2 equal parts. All right, so I used the first given. Okay? First given led me to those congruent segments, which means now I'm going to come back and I'm going to use the second given. Okay, I'm going to put that in. And so now I'm going to go with segment VR is parallel to segment AN. And I know they're parallel because it is given. That's the only way I know. So again, in the picture, I'm gonna mark that those are parallel. I'm gonna put the arrows in there, just so that I have them in the picture so I know what's going on. Which now, again, being parallel does not mean that those sides are congruent. It doesn't mean any of that stuff. But being parallel should lead you to something else. What do you think on this one? What does it lead me to here? Parallel lines. Therefore, what has to be true in this picture? What do you think? Amanda, what do you think?
Angle measure?
Okay, yeah, we know that parallel lines lead you to angle measures, angle relationships. So you should be looking for corresponding angles, alternate interior angles, things along those lines. What do I have? What do I have here, Amanda? Give me an example. You got a couple of options of congruent angles.
RA.
Okay, angle R has to be congruent to angle A then, because here's your letter Z right there. Those are alternate interior angles. Okay, but that's only true because the lines are parallel. So we stated that the lines are parallel, which then leads us to the fact that those angles are congruent. So we will put in here angle R is congruent to angle A because they are alternate interior angles, which I'm just going to abbreviate AIA. And if you notice, by the way, I only used one letter because there's only one angle R here. If I said angle R, you know exactly what I'm talking about. If I said angle I can't do it with angle I because there's multiple angles. That's where I'd have to use three letters again. Okay, so just a heads up on that. And now the rest of this proof, if you notice, I got 2 steps left. Completely depends on what you do next. There's 2 different ways to go. Okay, so what's one option? What's one option? What's something else that's true in this picture, either based on what you see? Karen, what do you got? Okay, so you could go angle N and angle B are congruent. Why, Tara? What kind of angles are those? That's another set of alternate interior angles. So that could be step 5 right there. You could say angle B congruent to angle N because of alternate interior angles. And therefore, the triangles are congruent because in the picture, what do you have? Which shortcut did we come up with? Yeah? What do you see in the picture? Not which, out of like side, angle, side, that kind of stuff. What did I now know that the triangles are congruent. But why? What do I have? There you go. Angle, angle, side. Okay, so you could finish up step 6 here, stating that the triangles are congruent, and the reason would be angle, angle, side. Now, I didn't write that down because I'm going to just talk about the other option, because there is another option. So you could go the route of angle B and angle N, alternate interior angles, and therefore angle, angle, side congruence. Or the other option on this problem, depending on what you see, some people might have come back and said, and not recognized that, but recognized instead that these angles are congruent. Why? What kind of angles are those? Those are vertical angles. So you might have, in step 5, said that those 2 angles are congruent because of vertical angles, which then means, now why are the triangles congruent? It's not angle, angle, side anymore. Now it's angle, side, angle. Okay? Both of them are right, okay? But it's 2 different ways that you could have gone with those last 2 steps, depending on what you see. And the biggest thing I'm going to tell you, as you go through, I told you there's 2 proofs on the test. The biggest thing that I'm going to tell you is, whatever you say here should match up here. Make sure the markings in your picture match up with what you have in your proof. Okay, that's kind of the whole point, is you're trying to, whatever you see, you then are writing it as a proof. Okay, so don't, if your picture says that, don't put angle, angle, side down here, because that's something I would go through and mark wrong. Okay, your picture has to match the proof, so make sure that it does. Okay, here's what I want you to do then with the rest of the time. We got about 10, 15 minutes left. I want you to take out your practice to learn packet, okay, your chapter 6 practice to learn packet. The next worksheet after the 614 is this one. Okay, there's, I believe, 11 questions. Congruent triangles proof worksheet. And I'll show you in a second what it looks like. I want you to start working on that in class. That way, if I can go through, I can kind of come and help you if you're struggling on something or you're not quite sure what to do next. And then also, here's your next Delta Math assignment, which, reminder, if you haven't done the G19 Delta Math assignment, that is due by Friday. That's due this week. Okay? D19 is due this week. This is the assignment that's due next week. Okay, so just a heads up on that. This is the assignment I was talking about right here, the congruent triangles proof worksheet. Couple of things on this. Notice I already have it set up for 2-column proofs. If you would rather do flowcharts, just kind of ignore that that's there and just do it in the space. Just right over the top of it. Put your bubbles there, arrows, all that kind of stuff. That's perfectly fine. Just ignore the statement and reason stuff. And use the space to create your flowchart if you prefer that. The only other thing I want to mention, if you go to the last page of this worksheet, well, maybe, where it's got 9, 10, and 11. Number 11, you can put down as a bonus question, kind of an extra question, or a challenge problem, or whatever you want to call it, okay? It's pretty hard, which is why if you don't get it, it's not the end of the world. Okay, it's one of those kind of those extra types of problems. But number 11 is that bonus type of question. See if you can do it. So I really want you to focus on the first 10. Okay, I'm going to get out of your way. I'm going to let you go to work and see where you're at. And like I said, I'll come around and check in with you and see if you have any questions as you work your way through this. Okay? Good luck. I'll be around.